Hi, this is Pranav. Today I am going to do my Unix and Linux lab 8th experiment, which is on process creation. In this we have three programs. The first one is write a C++ program to create a process hierarchy performing the following. Process A gets seconds as an input from the user. Process B calculates hours, minutes and seconds and print 18 hours, minutes and format. Print the process ID and parent process ID of each process. Let's see the program for this. And this is my program for first one. It is a C program, so it has a hash include studio.h, hash include unistd.h, and we'll go into our main. We will initialize seconds, minutes and hours. In printf, I have given parent process, which is given in which is stored in percentage %d. Get process ID. To get the process ID of the parent process, printf, enter the seconds. Scanf is given to take the input uh, of the given seconds, which is given by the user, and to store in percentage %d. Int PID is equals to fork. This is to tell that child process is created. If PID is equals to 0, then it will go to printf child process get PID, which is getting process ID and stored in percentage %d. Printf parent ID percentage %d, get PPID, which means get parent process ID. I have initialized hours, minutes and seconds accordingly, and this line is to store that given hours, minutes and seconds, else it will go into sleep. Now let's see the output for this. Enter the seconds and entering some 121 seconds. So parent process is created here. Child process is created here. This is the parent ID. I have given 125 seconds. It is converted into 2 minutes. Now let's see. Now let's see the second question, which is write a C or C++ program to create the following process hierarchy and perform the following. Process A reads string as input in the char. Process B reverses the string and displays. Process C checks the string for palindrome. Print the process ID and parent process ID of each process. Now let's see the code for this. Now first. This is my code for the second one, which is a C program, so it includes hash include string.h, hash include studio.h, hash include unistd.h, void main. These are the initializers. Here I have given printf to take the input for the process ID. Yeah, I have given get PID, which is get process ID for the given process. Printf, enter the string. Scanf percentages ampersand str, int l equals to str len in brackets str, which means this gives the length of the string. Printf, to store the length of the string, I have given string length is percentage %d. Int PID equals to 4, so if PID equals to 0, here we are creating a child process for the second one. By these two lines, the child process will be created. Here I have given printf child process percentage %d get PID, which will get the process ID. So for this child ID we have to create a parent process, so that I have given printf parent ID is some percentage %d get PPID, which gets the parent process ID. Here I have given I have given the um, to reverse the string. I have given some this includes for I equals to 0, I is greater than or equals to 0, str1 j plus plus is equals to str minus of minus I, which is to reverse the given string and gives the output. Now for the last one, which is to here to check whether it is a palindrome or not. For that I have given this. For that again we have to create a child process. For that int PID 1 equals to fork if PID equals to 0. To create child process, printf child process get PID. For this child process again we are getting a parent ID, which is get from which will get PPID. For that we are giving j equals to 0 for I equals to 1, I greater than 0, str1 j plus plus is equals to str minus of minus I. For this, if the given string this is given to check whether the given string and the reverse of it are equal or not. For that I have given if str comparison cmp str1 comma str equals to 0, then printf palindrome. Otherwise, if the given string and the reverse of it are not equal, then printf not a palindrome, else go to sleep. Now let's see the output for this. Now enter some string. So this is the length of the string. This is the parent process at first. This is a child process for the second one, and this is the parent ID for the child process. Reverse ID reverse of the string is given here, and again for palindrome this is the child process ID, this is the parent ID for this child process, and here it is comparing these two and it is showing not a palindrome. Now let's see the code for the third one. Let's see the question for it. Write a C or C++ program to create the following process hierarchy and perform the following. Process A reads an integer as input. Process B finds the factorial of the number. Process C checks Armstrong or not. Process D prints the Fibonacci series. Process E checks the number for prime. Process F reverse the number, and we should print the process and parent ID of the each processes. For this, let's see the program. This is my program. I have started with hash include. I had printf is equals to entering an integer. This is to enter an integer. In data from scanf here is to store the integer value. It is stored in percentage %d. Here we are giving PID equals to fork. This is to create. So here PID is given to create or initialize a child process. If PID equal to 0, here printf the process B is created, which indicates the child process is initialized. printf the parent id of the child process, and child id gives the child id of the process. This is the condition to check whether the number is a factorial or not. So for that, int I f equals to 1, for I equals to 1, I is less than or equals to n, I plus plus, f is equals to f into I. This condition checks the factorial of the given integer. And now let's check for the Fibonacci series. For that, we have to create another child process. So we have given PID 1 equals to 4. If PID equals to 0, this initializes another child process. Here another process D is created. Parent ID and child ID is given here by giving get ppid and get PID. Here this is the condition to check the Fibonacci series. While x minus 2 is greater than 0, D is equals to B plus C. Printf B equals to C, C equals to D, x minus minus, and this is stored in this printf percentage %D. Now let's check whether the given integer is Armstrong or not. For that, I have given initialized another child process PID2 equals to fork. PID2 equals to 0. Process C is created for Armstrong. The parent ID and child ID for that is given here by using get ppid and get PID. Here initializations are given. The given integer is stored in on equals to n, while on not equals to 0. Then a remainder r is equals to on percentile 10, result is equals to r cube. If result equals to n, which means if the result is given is equal to the given integer, then it will print the percentage d is an Armstrong number, else percentage d is not an Armstrong number. Now let's create another child ID to check whether it is a prime number or not. So for that, PID 3 equals to 4, if PID 3 equals to 0, then process E is created. Get ppid and get PID gets the process ID, parent ID and child ID for this initialized process. And this is the condition for this process. Int I c comma c equals to 0, for I equals to 1, I is less than or equals to n, I plus plus. If n percentage I equals to 0, this will check whether the given integer is a prime or not. If c equals to 2, means if the in C the given integer is stored, if that integer equals to, then it will print it as a prime number, otherwise it is not a prime number. Now for the last one, which is to get the reverse of a number, we are creating another child process by giving PID 5 equals to fork. If PID 5 equals to 0, process F is created. This is to get the parent ID and the child ID. These are all the initializations. This is the condition. While E is greater than 0, MO equals to E percentile 10, RE equals to RE into 10 plus MO. MO stores the um, resultant or the reverse of the given process, and stores the given integer. Printf reverse of percentile d is this will give the reverse of the given number, or else it will go to sleep. Now let's see the output for this. So it's giving a parent process A with some ID and asking to enter an integer. So process B is created. which shows the factorial. D is greater, which shows Fibonacci series. C is greater, which shows 4 is not an Armstrong number. E is created, which shows 4 is not a prime number. F is created, which shows the reverse of the given number. So this is the program, 3 programs for the process creation, which is the 8th experiment of the Unix and Linux lab. Thank you.